Hey, you! I said, hey, you! What's wrong? Has life got you all tied up in knots? Well, turn that frown upside down. A little bit of physics can solve all your problems.
So, you're trying to water that plant over there, aren't you? Why don't you look at where you're standing? Go on. Go mark it. Good. Go measure how far away the water lands. How far is that? Now, go get a watch. Good. How long does it take the water to fall?
How long was that?
You said 0.7 seconds? Okay. So now, all you have to do is use the second equation of Newtonian mechanics. That's right. First, we'll do it in the x direction. So, x final equals x initial plus v initial in the x direction times time plus 1/2 times acceleration in the x direction times time squared. You already know that your initial position is 0, and we just measured that the water was falling 7.5 feet away from where you're standing. We don't know what your initial and final velocities are going to be, but we just measured that it took 0.7 seconds to fall. So, just plug these variables into the equation, and we can find out that in the x direction, the velocity is 10.7 feet per second. Now, we do it in the y direction. We can use the equation final velocity in the y direction equals initial velocity in the y direction plus acceleration in the y direction times time squared. We know that the final velocity in the y direction will be when the water reaches the top of the parabola. At this point, the velocity in the y direction slows down to 0. So, 0 feet per second equals the initial velocity in the y direction, which we don't know, plus the acceleration in the y direction, which is a constant known as negative 32.1768 feet per second squared. We times this by the time it took for the water to fall, which is 0.7 seconds, do the equation, and we come up with the solution that the velocity initial in the y direction is equal to 22.5 feet per second. Therefore, if we add the x and y velocity vectors, we can find that the initial net velocity is 24.9 feet per second. And that is so that the water can travel 7.5 feet. But you said that the bush was 10 feet away from you. So if we do another equation, we can find that in order for the water to reach 10 feet away from where you're standing, the velocity would have to be 26.672 feet per second. Therefore, since you can't increase the velocity, you have to decrease your distance, so that the object of interest is only 7.5 feet away from you. Look at where you're standing. Now, 10 feet minus 7.5 feet is 2.5 feet. So, go on, walk 2.5 feet towards the bush. There you go. Keep going. Great! And, as I said, physics can solve all your problems.